In the last video, we went over solving quadratic equations, and we learned that a quadratic equation is one in which our highest degree term has a degree of 2, so our x is going to be raised to the power of 2. And we also learned that we are going to have two solutions for x in most cases. And we learned that the best way to solve those equations is to write down your equation in the form of ax squared plus bx plus c, and then factor this into a form where we have, let's say, x plus p and x plus q, and this could be plus or minus. We might have a coefficient here, so let's say we would have like m or n or whatever we have. We are going to put it into a form where we have factored it in brackets, and then we can solve for x very easily, and we can see that in a case like this we're going to have two possible solutions for x. And in this video we're going to go over a few more examples to really make sure that we understand this concept really well. So let's start off with another example. Let's say we had negative 3x squared plus 27x minus 54 is equal to 0. So the first thing that we can notice is that we have a common factor in each of these terms, and that common factor is negative 3. So we can factor out negative 3, and if we factor out negative 3, we're going to get x squared minus 9x plus 18. That's going to be equal to 0. And now we can divide both sides of the equation by negative 3 in order to cancel out this negative 3 here, and that's still going to set this side equal to 0. So if we divide both sides by negative 3, and we're going to end up with x squared minus 9x plus 18 is equal to 0. And now we can solve this by factoring, and we have a leading coefficient of 1, so we're going to have the really easy way of factoring where we just find our two numbers, and we need our two numbers to multiply together to give us 18 and to add together to give us negative 9. If we're looking at factors of 18, we can use, let's say we used negative 3 and negative 6. Negative 3 times negative 6 is going to give us 18, and minus 3 plus minus 6 is equal to negative 9, so that's going to work. So our two numbers are negative 3 and negative 6. Now if we're solving for x, either of these brackets has to be equal to 0, so x is either going to be equal to 3 or x is going to be equal to 6. And those are our two possible solutions here. And again, you can plug these two numbers back into this original equation and see that you actually do get 0. So if you want, you can pause this video and plug in 3 for x and see if you get 0, and then plug in 6 for x and see if you get 0, and you'll find that in both cases you are going to get 0, so you know that you've done this correctly. Let's go over another few examples. Let's say we had 16x squared minus 25 is equal to 0, and what should immediately come to mind is that we have a difference of two squares here. The square root of 16x squared is equal to 4x, and the square root of 25 is equal to 5. So we have a difference of two perfect squares here. And we'll recall that when we are factoring a difference of two squares, the way that we're going to do that is by taking the square root of each of our perfect squares, and we're going to have a bracket in which we add those together and a bracket in which we subtract those together. So we're going to have 4x minus 5 and 4x plus 5. And now if we are setting that equal to 0 and we're trying to solve for x, we're going to have x is equal to 5 over 4, or x is equal to negative 5 over 4. So these are going to be our two possible solutions for x. And you can double check that we've done this correctly by just plugging in 5 over 4 for x or negative 5 over 4 for x, and seeing if you get the right answer. Now let's say you were given the following equation. Okay, so one thing that we can see is that this equation here is not in a form of ax squared plus bx plus c is equal to 0. So that's one of the first things that we want to do. We want to get this equation here into this form. And once we have it in this form, we know how to factor it. Let's actually move this 2x to this side, and then that would be equal to 0. So if we were to move this 2x, we would get 1/3 x squared minus 3x minus 2x. Since we moved this 2x to the other side, it becomes minus 2x plus 14 2/3 is equal to 0. And we can simplify this, so let's just simplify that quickly. We have 1/3 x squared minus 5x plus 14 2/3. So let's actually simplify this 14 2/3 and write it down as a improper fraction. So the way that we're going to do that is we're going to multiply 14 times 3, and we're going to add 2, and that is going to give us 44/3, and that is going to be equal to 0. And now, if we look at this, it's going to be a bit difficult for us to factor when we have this fraction as a leading coefficient. So the easiest way for us to actually tackle this problem is to try and get rid of these fractions here. And one way that we can do that is to multiply both sides of this equation by 3. And by doing that, this is still going to be 0 because 0 times 3 is equal to 0. But if we multiply this entire side of the equation by 3, we're going to get x squared minus 5 times 3 is equal to 15. So minus 15x plus 44 is equal to 0. And now we can factor this the same way that we've been factoring things in the past. We have a leading coefficient of 1, so it's going to be an easy method of finding two numbers that multiply to give us 44 and are going to add together to give us negative 15. And something that pops out to me immediately is if we were to multiply negative 11 and negative 4, we would get 44. And negative 11 minus 4 is going to give us minus 15. So these two numbers do fit that profile. So we can have x minus 11 and x minus 4 and set that equal to 0. And now if we're solving for x, either of these brackets can be equal to 0. So we're going to have either x is equal to 11 or x is equal to 4. And those are our two solutions for this equation. And again, you can also validate that this is true by plugging in either 11 or 4 for x in our original equation, and you'll see that if you pause this video and do that, you're going to get the right answer. Now let's say you had this example, and this is also an example of a quadratic because we have our highest degree term as a second degree term. If you are just trying to solve for x, you can just take the square root of both sides. If we took the square root of x squared and the square root of 9, we would get x is equal to 3. But one thing that you have to remember is that this is not your only solution. X can also be equal to negative 3 in this case. And that is because if we had negative 3 squared, let's say we had negative 3 squared, that is still going to be equal to 9 because a negative times a negative is a positive and 3 squared is 9. So that is the same thing as if we were to do 3 squared, which is also equal to 9. So our two solutions here are x is either equal to 3 or x is equal to negative 3. And I think it's worth just noting here that whenever you're doing something where, let's say you have something squared and you're taking the square root to solve for that variable, you had a and we're trying to then take the square root of a. We're taking either positive or negative the square root of a. So I think that is just worth noting here. Let's go over one more example in this video. 4x squared minus 17x minus 77 is equal to 0. Well, because we do not have a leading coefficient of 1, our leading coefficient here is 4. We're going to have to factor by grouping. And when we factor by grouping, we know that we have a similar method to when we have our coefficient of just 1. In that we have to find two numbers that multiply together to give us, well, instead of just giving us negative 77, they're going to need to multiply to give us negative 77 times 4. And that is equal to negative 308. And we're going to need to find two numbers that add together to give us negative 17. And unlike when we have a leading coefficient of 1, we are going to use the two numbers that we get here to actually break up this middle term, and then we can factor by grouping. So if we try to look for those two numbers here, let's start by looking at our factors of negative 308. Because this is a negative, one of our numbers will be negative and one will be positive. But for now, let's ignore this negative sign and just look for are factors of 308. So we have 308 and 1. We have 154 and 2. 2 times 154 will also give us 308. 308 is not divisible by 3, but we have 4 and 77. 77 times 4 is equal to 308. We have 11 and 28. 11 times 28 will give us 308. And if we look at this pair, actually, this pair is going to work. Let's say we had negative 28 and positive 11. We know that one has to be negative and one has to be positive to give us a negative number when they're multiplied. And if we look at this, minus 28 plus 11 is going to give us negative 17. So this pair actually works. So let's break up this negative 17x into minus 28x plus 11x. So we have 4x squared minus 28x plus 11x minus 77 is equal to 0. And again, all that I've done here is break up this minus 17x into minus 28x plus 11x. And minus 28 plus 11 is just minus 17. So this is another way of writing down exactly the same thing up here. But now we can actually factor this by grouping. And we have our two groups. This is going to be our first group, and this will be our second group. And when we're factoring by grouping, when we look at this first group, we can take out a 4x, and we'll be left with x minus 7. And here we can take out a plus 11. And if we take out an 11, we're going to be left with x minus 7. And that is going to be equal to 0. So now we have x minus 7 and x minus 7, so we can factor out our x minus 7. And we're left with 4x plus 11. So we have 4x plus 11. And those are going to be our two brackets. So we can also validate that we factored this correctly by expanding this out. And you'll find that when you expand this out, you're going to get exactly what we have here. And now to solve for our x's, we know that either x minus 7 has to be equal to 0. So in this case, x would be equal to 7. Or 4x plus 11 is equal to 0. And in this case, x would be equal to negative 11 over 4.